All right, so we will go over these questions together. Okay. Now, what you should expect to see on the quiz is that we will likely give you something not factored. So you have to be ready to factor them. Okay. So if you factor them, hold on, black. All right. So if you factor it, you will get x plus 2 and x minus 1 for the top. And then you have x minus 3 and then x plus 2 at the bottom. And what you can see here is that something cancels out. And what does canceling out mean? Remember? If you cancel something out, there's a hole, right? So again, it screams that there's a hole. So we know the hole, it's going to have the coordinate of -2 because x cannot be -2, even though we cancel the x plus 2. So again, every single action should be supported by a solid reason. Okay. And then, so after simplification, yes?
Why is it negative?
Good question. Now the question, the reason is that when you have x equal to -2, what happened to that parentheses? And then you are multiplying 0, right? So the whole denominator becomes 0. So the question was, why is it -2? And we say, oh, if you have -2 for this parentheses, for the x here, that would make this parentheses equal to 0. You multiply 0 for the denominator, the whole denominator becomes 0. And when the whole denominator becomes 0, the whole fraction is undefined. So that's not a good thing to have. All right, so let's go ahead, write down the simplified expression. So we have x minus 1 on top and x minus 3 in the bottom. So this is what we would graph. Graph this, and I'm going to put a little asterisk right here because we have to take care of the whole. Right, so it's not entirely this one, just have to take care of the whole. Now, since we're talking about the whole, now there's no any particular order to do things, as long as you know what to do. So since we're talking about the whole, let's go ahead and think about the whole. So the whole is going to be f of -2. And we can put the -2 into the simplified expression so that we will know what's the y value of the whole. So -3 over -5, it's equal to 3/5. So our whole, it's going to be at -2 comma -5. Oh no, -2 comma 3/5. So it's going to be somewhere right around here. Okay, right around there. Any question at this point about how we get the whole? So again, we saw the cancellation that's screaming at you like, there's a hole. So we know the x coordinates for the whole because x cannot be, in this case, -2. There's a solid reason back there. And then we just put the -2 into the new simplified function to see, oh, so we would have graphed that point, but since there's a hole right there, we want to know the y value of the hole. Now, something that's very easy to extract, a vertical asymptote is very easy to extract. What's vertical asymptote? X equals to 3. Because if x is equal to 3, the denominator would become.
Good afternoon, teachers. The band is practicing on the lot in about 10 minutes. We need you to move your cars as soon as possible. Thank you so much.
let's go over this question and then I'll go move my car. So that's vertical asymptotes, very easy. Other things that are also very easy as well, x-intercept and y-intercept. Okay, x-intercept is when you have 0 for y. So we say 0 is equal to x minus 1 over x minus 3. Now, two ways to explain this. We'll give you two ways. One is that you can say, oh, let's go ahead and multiply the denominator on both sides. So you would end up x minus 1 equal to 0. The other way to explain is that, that's my way. My preferred way is that if you have a fraction that's equal to 0, the numerator must be 0. That goes to your conceptual understanding of what a fraction is. So that's why I like that better. Again, if you have a fraction equal to 0, that means the numerator must be 0. So I have x minus 1 equal to 0, so x is equal to 1. So 1 comma 0. Right here. Okay. And then we say, what about the y-intercept? Y-intercept, it's when the x equals to 0. So you have -1 over -3, which is basically 1/3. So your y-intercept is 0 comma 1/3, which would be somewhere like right here. Okay. So these are the easy stuff. Now, the slightly harder stuff, it's going to be the horizontal asymptote. And this horizontal asymptote, it's going to be, again, there are two ways you can do this. You can go with the handout. You can read that, read the little page. It tells you what to do, or you go with my way, which is the conceptual understanding, which is that as x goes to infinity, f of x will become, well, my way of explaining is that, well, if x is going to become infinity, like a big, gigantic number, -1, come on, it's not going to affect anything. -3, no. So we can reduce it down to x over x, because the -1 and -3 is not going to make a dent to infinity. So what's x over x? 1. So therefore, the horizontal asymptote is y equals to 1. Okay? Yes? If, okay, hold on. Let me write down the if. If what again? Okay. 2, yes. Okay, so the question is if, okay, the f of x is equal to this. So the -3 got canceled out because they're not important. So you just have 2x over x. You cancel the x out. That's why you just have 2. So that's why on the paper, it tells you what to do when the power, when the degree, when the exponents have the same power. Oh, I mean, when the polynomial has the same degree, you just look at the leading coefficient. But the idea is that when they are the same, so you reduce everything else, you just cancel that out. Okay, so so now we basically have everything here, and we can make a graph. So with the points that we have, we can draw a pretty decent graph. Okay, and so we have one part of the graph drawn, and then again, for the graph that we're doing, we can safely assume that it's going to be drawn in a diagonal quadrant. Okay, And the other thing to help us verify is that it cannot be drawn in the bottom half, because if you draw on the bottom half, it would have to cross the x-axis one more time. That would mean that we should have one more point that's found earlier, but we didn't. So that kind of confirms us that we will draw on the upper half. There's no slant asymptote because if you have horizontal, there's no slant. The discontinuity, well, is on your worksheet, is it discontinuity? Okay, let me go ahead, change this, it's discontinuity. So we ask, hey, what x value is the graph not continuous? Well, it was not continuous at the whole. It was not continuous at the asymptote. And the domain is going to be negative infinity to negative 2, and negative 2 to 3, and 3 to infinity. Okay, so if you know the discontinuity, you know the domain. So I would say you can highlight this if you want to. You can say that's the vertical asymptote, whole, discontinuity, and domain. They're all interrelated to each other. And for the range, since we have the whole as well, so we have negative infinity to 3/5. That's a whole. And then from 3/5 to 1, because it doesn't seem like any there's any crossing of the horizontal asymptote, and then from 1 to infinity. Okay. Again, for domain, you scan the graph from left to right and see where you stop. For range, you scan the graph from bottom and up, and you stop right here where the hole is, and then you keep going, and then you stop at the horizontal asymptote, and then you just keep going upward. Question?
So in the domain and range, you include the vertical and horizontal asymptote.
Well, now the way I'm going to put it is that just look at the graph and see what it includes and what it doesn't include. Because if you put it that language, that sounds like you're going to memorize it, and that's dangerous. I mean, the answer is on the graph. So if you know how to graph it correctly, that's already very good. So now, yes. This one? Yeah. Yeah. Hold on. Let me finish this first. And then I need to move my car. All right, now, so as x goes to negative infinity, where does it go to? As x goes to negative infinity, what y value does it go to? 1. And as x goes to positive infinity, what does the function go to? Where does the function go to? 1 as well, okay. So again, this is the definition of horizontal asymptote. These two are the definition of horizontal asymptote. Okay.